Assemblies contain modules. Modules contain types. And types contain members. For some of you, that's probably well known, but even then, it is useful to look into this as we will encounter these concepts throughout the course. Assemblies form the fundamental units of deployment, version control, reuse, activation scoping, and security permissions for .NET-based applications. An assembly is a collection of types and resources that are built to work together and form a logical unit of functionality. Assemblies take the form of executable files, .exe, or dynamic link library files, or DLLs. They are the building blocks of .NET applications. They provide the common language runtime with the information it needs to be aware of type implementations. It thus contains type metadata. This is important to remember. We will encounter this again throughout the course. Up next are modules. If we look at the definition of a module, we read, well, almost the same. A module is a portable executable file, such as type.dll or application.exe, consisting of one or more classes and interfaces. There may be multiple namespaces contained in a single module, and a namespace may span multiple modules. One or more modules deployed as a unit compose an assembly. So in principle, an assembly contains one or more modules. In the .NET world, however, this is largely a theoretical thing. Multi-file assemblies would require you to use a custom command line compiler instead of the one built into Visual Studio. So, while the hierarchy is there, you will see a one-on-one match between an assembly and a module in 99% of the cases. A module contains types. But what's that then? You can look at a type as a collection of members, fields that hold data, methods that can be executed, and so on. A class is a type, a struct is a type, an enum or enumeration is a type, and so on. In fact, every variable and constant has a type, as does every expression that evaluates to a value. Types contain a lot of information, like the base type it inherits from, the interface that it implements, the kind of operations that are permitted, and so on. This metadata is important when working with reflection, as we will learn soon. Such a type contains members, and that is the last piece of the puzzle. Members of a type represent its data and behavior. Examples are fields, properties, constructors, events, methods, and so on. Alright, now what does all of this have to do with reflection? Let's have a look at what reflection is, and this is coming straight from Wikipedia. The definition wasn't written with C# in mind, but it does perfectly fit. In computer science, reflection is the process by which a computer program can observe and modify its own structure and behavior. And that's it, really. By using reflection, we can alter applications at runtime. First, we need to get the metadata of a type. There's that metadata already. And once we have that, we can use that metadata to modify our application while it's running. That may sound a bit theoretical, right? Let's try explaining this differently. Reflection provides objects that encapsulate assemblies, modules, and types. We can find these in the system.reflection namespace. You can use reflection to dynamically create an instance of a type, to bind the type to an existing object, or to get the type from an existing object. And once we have that, we can invoke the type's methods or access its fields and properties, even private properties. So the stuff the designer of the class didn't intend to be fiddled with. Very practically put, say that we only know the name of a type, for example, mail service. So all we have is that string value, mail service. That is enough already. With that information, we can use reflection to search the assembly for such a type, create an instance of it, and call methods on it, all dynamically at runtime from that string value. That's pretty cool, right? Let's have a look at some more use cases and some potential drawbacks to consider.